So let us prove this theorem. So H and P an increasing sequence, then it is convergent if and only if it is bounded above. So what does it says? So this theorem is equivalently states that let Hn be a monotone and Hn is convergent if and only if it is bounded. So this is what we can summarize this theorem. We have a set Hn which is non-empty and bounded above. So by LUB property, LUB exists and I am calling it as L. And we have to, our aim is to say it is convergent. Since we have taken it is monotonically increasing and bounded above, now our aim is to say Hn converges to, that is Hn converges to L. That is what we have to say. So this is the LUB property of a real number R. So this is what the statement is about. So this proportion is a particular case of this one. That is, monotone means I am taking it as a monotonically increasing sequence. Now I have to say it is convergent if and only if it is bounded above. This is the representation of a increasing and bounded above sequence. So a sequence is increasing, but it is bounded above means what happens is there exists a nth stage after which this y will lie between L minus epsilon to L plus epsilon. So that is what we know about convergence. Then it is said to be y converges to L. So there should be existing some stage n. So this is the idea over here to solve this theorem. Theorem, we have taken an increasing sequence and it is bounded above. We need to say that it is convergent. For that we are using the epsilon definition for proving that it is a convergent. So here by the Archimedean theorem proof, we know that L is the least upper bound. So L minus epsilon cannot be an upper bound. So L minus epsilon is, so we know that the sequence is denoted by Hn. So L is the least upper bound for Hn. L minus epsilon cannot be the least upper bound for Hn. Hence L minus epsilon is obviously less than L because epsilon is a positive number. So this is the intuitive idea. Now what I am going to say is there exists something in between. Something means some element of Hn in between L minus epsilon to L. So that is I am denoting it by there exists H capital N such that Hn will be greater than L minus epsilon. So Hn will be greater than L minus epsilon, but it will be obviously less than or equal to L since L is the least upper bound. Hence I can also say that it is strictly less than L plus epsilon. So this is already we have saw in the Archimedean property. Archimedean property we used to prove by L is the least upper bound. So L minus alpha. So for the notation I am just using the same notation. B will be the upper bound minus y. Y is one of the number. So x greater than 0, y greater than 0. So y is one of the number for saying that. So b minus y is lesser than py, which is lesser than b, because b is the least upper bound. So this is we have seen in the Archimedean property. You can check it. Okay. So okay, I have done a mistake. It is Hn because that is the stage. This is not varying. This is fixed because n is fixed. N is something like some number, some 100, something like that. So Hn will be varying because we are varying that n. So like n is greater than or equal to n, some stage. So n is fixed, whereas Hn will be varying. So you have to note that. So here we are. So Hn is less than or equal to L, which is less than L plus epsilon. So now we know that we have taken a monotonically increasing sequence. So by definition, what do you mean? Hence we have got Hn, that is Hn will be less than or equal to Hn. So I have something in between. Okay, like this. So this is my intuitive idea behind proving this one. So this is what we have got, and hence I can say that picking up this one and this one and this one, what I'm getting is I can omit this and this. So I have got that Hn is lying between, okay, I have missed one inequality, because as you can see Hn will be strictly less than L minus epsilon, and strictly less than strictly less than L plus epsilon, and strictly greater than L minus epsilon. So I can write it as like this. So Hn will be lying between L minus epsilon to L plus epsilon. Hence, I have proved that this is the definition for the convergence, and I have seen say that this Hn converges to L. So now my converse part is, if it is convergent, I have to say that it is bounded